Welcome back. In this particular module, we will see how the integrator can be designed using an operational amplifier, right. So, when you talk about integrator, it performs the function of integration, that is why at the starting of the op amp I told you that operational amplifier can be used to solve the mathematical functions, right, mathematical functions. So, let us see how you can design a op amp to work it as an integrator. Okay. So, if you come to the screen, what you see is integrator is a circuit whose output is proportional to the negative integral of the input signal with respect to time, right. So, here what we have done, we have a resistor as a input, but in the feedback we have used a capacitor, okay. And if I solve it, what will I have? I will have VO would be minus 1 by RC 0 to t V in dt. VO would be minus 1 by RC 0 to t V in dt. Okay. It will integrate the input signal V in, alright. So, once again if I see the definition of an integrator, it is a circuit whose output is proportional, right, this output voltage is proportional to the input, to the integral, to the negative integral of the input signal with respect to time, Feedback is given through capacitor to the inverting terminal, right. Now, since the same current flows through R and C, right, you see here current I1 flows through R, goes through I1 goes through C, right. Same current I in flows through R and C. Since same current flows through R and C, we have I here, if I want to measure here, right, what will be here? It will be V in by R equals to I in. If I want to measure here, then what will I have? I will have minus C into dVO by dt, correct, minus C into dVO by dt, or VO equals to if I want to find VO from this equation, this is very simple mathematics that we can use. We have to integrate minus 1 by RC into V in dt 0 to t, correct. From this equation, if I want to measure, if I want to find the value of VO, or if I want to derive the equation of VO, then what I can do? I can have the integration of minus 1 by RC, right, into 0 to t V in dt, right. Now I know that, okay, this is the formula for the integrator. Let us solve a problem for the integrator, alright. So, if you are given this circuit, an integrator as shown in figure has Vc equals to minus 1.4 volts, this Vc equals to minus 1.4 volts across capacitor at time t equals to 0. A step voltage V in here minus 2 volts is applied, alright, at time t equals to 0 again. Determine the RC time constant necessary such that output voltage reaches. So, VO equals to 10.2 volts at time t equals to 5 milliseconds, right. This is what we have to find. What we have to find? We have to find the RC time constant. So, if I want to find the RC time constant, first I know that my formula for integrator is VO equals to Vc, right here. If I just want to find the formula for this one, output voltage will be nothing but VO equals to Vc, right, minus 1 by R1C2 integrated by V1 dt, correct. So, if I substitute value, so what is the value? From 0 t equals to 0 to t equals to 5 millisecond. So, here I can substitute 0 to 5 V1 dt. So, output voltage VO is what? Output voltage VO is 10.2. So, 10.2 equals to minus 1.4, which is my Vc, and then I substitute this value from 0 to 5, right, dt. Then what will I have? When I substitute the value, I can find my value of R1C2 to be 0.862 millisecond. 0.862 millisecond is my RC time constant, alright, is my RC time constant when I am given a integrator, when I am given a integrator circuit to work on. Okay. Let us take another example. So, again integrator is also used to change the signal, alright, or change the shape of the signal. So, it is a shape generator also, because if I apply a square wave, I can obtain a triangle wave, and this we will see in the experimental section, alright. I will show you how the integrator can be worked, we can design the integrator in the experimental section, okay, when we perform the experiments. When we perform the experiments, I will show you how you are applying the input voltage in which particular signal is applied, and what is the signal at the output voltage, whether the shape is changed or not. So, here for this particular problem, what we are asked to find? We are asked to find the output for the op amp integrator shown in figure for an input of 5 kilohertz. So, he is saying that if I apply the input of 5 kilohertz, I had to find the output voltage. Okay. So, we know this value, right, we know this equation. Now, R equals to 10 kilo ohm is given, C equals to 10 nanofarad again given, right. So, input is constant, and so what is his here voltage? Voltage is peak to peak voltage is 2 volts, right. So, it is 2 volts and it is constant from 0 to 0.1 milliseconds, and from 0.1 milliseconds to 0.2 milliseconds. That is for the output of each of these half periods will be ramp, right. So, if I apply this input, my output will be for each of these half period would be ramped, and thus the expected output will be triangular wave. So, if I apply this one, right, if I apply this signal, I have to see how my capacitor will charge, and on charging and discharging of the capacitor, I will get the triangular wave at the output. Alright. So, this is how the integrator would work. Now, in the next module, what I want to show you is what is the differentiator. Now, integrator, what we have seen, if I take an example of the inverting amplifier, and if I take an example of the integrator, the thing that is different on non-inverting amplifier, the main thing in integrator was that now the feedback is given through the capacitor. So, that becomes our integrator, our input resistance R, feedback capacitor C, integrator. But if I change the capacitor from its point, its feedback, to the input, and I have feedback resistor, then my circuit will become a differentiator. We will see the differentiator in the next module. Till then, you just quickly see the integrator. Try to implement the circuit on the breadboard. It is very easy. You have to use function generator, you have to apply a DC power supply because you are using op amp. If it is a 741 op amp, you have to apply plus minus 15 volts, you have to apply plus minus 2 volts peak to peak, 2 volts peak to peak with a frequency of 5 kilohertz. This is a square wave, and when you see the output at the integrator, what you will be able to see is that you can see this output with the help of oscilloscope. It can be CRO, it can be DSO, and you will be able to see that on applying the square wave, the output will be triangular wave. That means this integrator can also be used as a waveform generator. Differentiator and integrator both circuits are also used as a filters. Okay, are also used as filters, which will be our next lecture. So, I will see you in the next module, and we will see quickly very short module which will show the op amp as a differentiator. Till then, you take care. I will see you in the next module. Bye.